Assalamu alaikum wa rahmatullahi wa barakatuh. This is chapter 7 from the Algebra 2 book, Exponential and Logarithmic Functions. These two graphs were in lesson 7.1 and these two logarithms were in lesson 7.3. Okay, so 7.1 was talking about exponential functions and 7.3 was talking about logarithmic functions. Okay, and I have reviewed with you before these graphs and the difference between them and how to translate them, stretch them, reflect them, and all of that. Okay, just to remind you about the basic parent functions or parent graphs. Okay, so this is the graph of an exponential growth. The exponential growth is f of x equals b to the power of x. Remember, exponential functions, the x always has to be in the power. Okay, so there is a base raised to the power of x. If this base is greater than 1, the graph would definitely look like it's an increasing function. And these are the examples: y equals 2 to the power of x, y equals e, which is 2.7, e to the power of x is also having this graph. And here in this graph, the asymptote is the x-axis. This graph as a parent function would never intersect the x-axis. Regarding the exponential decay, again it's f of x equals b to the power of x, but this time this b is greater than 0 or less than 1. Okay, so the graph would be, for example, y equals half to the power of x, 1 over 3 to the power of x. The graph is a decreasing function. As I go to the right, the graph is decreasing and also has an asymptote at x-axis, and this is supposedly -1 and 1 over b, wherever the 1 over half comes in the place of b, and this is 1 with b, and 1 and half, and this is the decreasing function. When I started introducing this lesson to you, or this chapter to you, I told you that inverses of exponentials are logarithms, and inverses always are have the same graph but reflected on y equals to x. Or again, in inverses, wherever that was x becomes y in the other graph, and wherever that was y becomes x in the other graph, in its inverse. Okay, so here is a logarithmic growth graph. If you look and compare these two, it's the same graph but reflected on y equals to x. This is y equals to x. If I reflect it, it would look like this, and here it is. So for a parent function of a logarithmic function, f of x equals log base bx, when b is greater than 1, this is a logarithmic growth. And this graph is increasing. As I go to the right, it is increasing. And this is 1 over b with -1, 1 and 0. Instead of 0 and 1, it became 1 and 0. And this is b with 1. For logarithmic decay, okay, the graph is decreasing, and again, it is the reflection of this graph on the line y equals to x. If I imagine the line y equals to x, this piece comes up here, and this piece comes in quadrant 4. And the graph looks like this for a logarithmic function in which b is greater than 0 but less than 1. So this is how these chapters started, and we spoke about the translations many times. When I have, for example, a -2 to the power of x, the graph is reflected on, if it's outside, it's reflected on x-axis, so better than here. Instead of here is there. So if I have the negative over here, it's reflected on y-axis, so it will look like this, and this will come here and this will come there. And if I have, for example, 2 to the power of x plus 2 outside the function, then I'll move the whole graph 2 units up. If I have it here, x plus 2 over here, then this is inside the function, and I will move 2 units to the left, not to the right. Okay, and you can review this part. And now mainly I want to focus on solving about logarithmic functions. Okay, so 7.1 was introducing exponential functions and exponential growth and exponential decay, and was all about graphing and translation. In that, you will not graph in your test, but you have to have an idea about the translations. As I said, I'll give you a couple of examples just to state the domain and range from 7.1 in your book. For example, let's say number Just a second. Okay, I'll get you number 20, I guess, from your book. Okay, for number 20, I'm not going to graph. Supposedly, we wanted to graph. All of these are exponential functions where the x is in the power, okay? And over here, if I want to know the domain and the range, okay? Type. Let's go back to the original function and discuss domain and range again. For the original function, okay, both of them, the domain is all real numbers, and always over here domain is all R because there are no x's, all real numbers. There are no x's excluded from these graphs. We need to discuss the y. If I have a number here plus 2, for example, then the domain is greater than or equal to 2, for example, and so on, okay? If I don't have a number, then it's greater than, without equal, I'm sorry, greater than 0. If I move down, then it's greater than. If there's a reflection, I will start saying less than, not more than, because if this graph is reflected over here, for example, like this, then I'll start saying its range is y less than 0 and not more than 0 if there is a reflection on x-axis. So for this graph, I would definitely just say the domain are all reals, or we can just write from negative infinity to infinity like your pre-calculus book. And over here, there's a reflection on x-axis. So I'm expecting the graph, instead of looking something like this with an asymptote at 3, because I've moved 3 units up, I'm expecting the graph to look like this with an asymptote at negative 3. So I would take this number and say then the graph is, the range is f of x less than 3. Okay, so again, if the graph, for example, I've moved it 3 units upwards, there is a movement right and left, but it does not affect me in my domain anyways. So I moved my asymptote that was y equals to 0 to, for example, y equals to 3. And let's say the graph, this is a decay, right? So as we said in the decay, the graph looks like this. صح? So if I reflected, if I reflected on the x-axis now, I'm going to reflect it on this line instead of the x-axis. So the graph would definitely look like this. Okay, the new graph will look like this. So this graph as a less than 3, because it will never intersect the 3, and anything less than 3. So y less than 3 is the range. So question number, this helps you with the range. If it's not there, then it's 0, y greater than 0, and if there is a negative y less than 0, if there's no number outside the function that is responsible for vertical translation. F of x is equal to 3 and 2 over 5 to the power of x minus 3 minus 6. Again, regarding the domain, I would just write all reals or negative infinity to infinity. This one, I can write it, since it's less than 3, I can write negative infinity 3 opened. Okay? Now, for the range, this decides the range. I'm thinking f of x greater than negative 6. Yeah, and I'm right. Why am I right? Because there's no reflection. So originally f of x is greater than negative 6. Or I can write it from negative 6 open to infinity opened. Okay? For example, let's say question number 20. Let's say question number 22. Okay, here's the camera. F of x is equal to half 1 over 5 x plus 5 plus 8. Okay, let's discuss the translations. Also, sometimes we have these questions, okay, in the test. Plus 8 is a vertical translation 8 units up. This plus 5 is a horizontal translation or phase shift 5 units left. Okay, this half is outside, it causes vertical compression. Okay, and this number that is raised to the power of x is the one that I decide from it whether it's exponential decay or exponential growth. This shows me that it's exponential decay, and since a decay, the graph must look something like this. Okay, regarding the domain, you would just write all R, and for the range you would just say f of x is greater than 8. Okay, greater than 8 means 8 to infinity opened, and there's no equal sign because 8 is an asymptote now. Instead of the y-axis, instead of the x-axis, now 8 is the new asymptote, and the graph would never intersect 8. Okay, this is regarding some questions from 7.1. 7.2 was mainly about solving exponential equations and inequalities, and inshallah we are good with that. I'll go through a couple of questions only. For example, let's say question number 9, 8 to the power of 4x plus 2. Here they did not introduce logs, so you have no option except to make the bases equal to each other, and so the powers will equal to each other, because we know if a to the power of x is equal to b to the power of y, then x is equal to y. So I think this is a good option for me to say 64 is 8 to the power of 2, and if the bases are equal, then the powers are equal. So 4x plus 2 is equal to 2. So 4x is equal to 0 and x is equal to 0. Okay, so there's no option to make these two equal, instead to make x equals to 0. So 8 to the power of 2 equals 8 to the power of 2. Let's say I have for example question number 14, 8 to the power of 2y plus 4 equals to 16 to the power of y plus 1. I think I would go for this to change it. I think this should be 2, right? Because 4 will not work. 4 to the power of nothing would give me 8. But if I change this to 2 to the power of 3 to the power of 2y plus 4 equals to 2 to the power of 4. Okay, and then start saying then the powers are equal to each other. So 6y plus 12 equals to 4y plus 4. I distributed in the same step. So 2y equals to 4 minus 12, which is negative 8. So y is equal to negative 4. Okay, this is a sample of the questions in this lesson. And we also have inequalities. Okay, like question number 7. Just a second. Okay, remember, if you divide or multiply by a negative 1, you will have to flip the sign. So 4 to the power of 2x plus 6 is greater than, the question is less than or equal to 64 to the power of 2x minus 4. I think I would go for 4 to the power of 3. That would give me 64. طيب, so less than or equal to 4 to the power of 3. Remember that this 3 has to be multiplied by the 2x and by the negative 4. So 2x plus 6 is less than or equal to 6x minus 12. So if the bases are equal, then the powers are equal. Oh, if this is less than this, then this is less than or equal to this. Okay, and then I would maybe take this here and take that there. I'm gonna end up in 4x greater than or equal to 12 plus 6 is 18. So I have x, this is greater than, I would just write it this way, greater than or equal to 18 divided by 4, which is 4.5. And if you have a calculator and you want to check, as we said, I can try 5, for example, I can try 6. These are, if I wanted to show you one with fractions before I end this video and start another video, okay? So 8, let's say 25 to the power of y minus 3 less than or equal to 1 over 125 to the power of y plus 2. Okay, I think I can bring this up and change it to 25 to 5 to the power of 3. 5 to the power of 3. Now I'm thinking this is 5 to the power of 2 times y minus 3. Again, I will have to multiply them by both. Less than or equal 1 over 5 to the power of 3. to the power of y plus 2. Okay, if I want to bring this 5 up, I'll make it negative 3. So 5 to the power of 2y minus 3 less than or equal to 5 to the power of negative 3 times y plus 2. Now the bases are equal, the powers or less than or equal, the powers are the same. So here 2y minus 6 is less than or equal to negative 3y negative 6. I'll change places. Anyways, these will cancel each other, I think. So I will have 5y less than or equal to 0. So y less than or equal to 0 is the answer. Okay. Okay, I'll move on with 7.3. 7.3 was the logarithmic one. Was the logs, and I introduced somehow, I introduced the graphs log base bx equals to y. If you want to change this to exponential, it must be b to the power of y equals to x. So if I have, for example, log base 3, 27 equals to y, then I always start with this to the power of this. 3 to the power of y is equal to 27. And let's say if the question they want you to evaluate log base 2, 8. So what should be the answer? It's 2 to the power of something, which I don't know. Let's set it equal to x. So 2 to the power of x is equal to 8. So what is x? When 2 to the power of x is equal to 2 to the power of 3. So definitely I'm thinking quickly that x must equal to 3. So remember the base, the base to the power of answer to the power of the answer equals to what was inside. Okay, so 2 to the power of x is equal to 8. Here 3 to the power of y is equal to 27, or b to the power of y is equal to x. This is how we started, and this lesson was mainly changing from exponential to logarithms and from logarithms to exponentials. For example, from your book, question number 13, they want you to write in exponential form. I'll not do much of those because I know you're good in them. Maybe 2. So it should be 2 to the power of 4 equals to 16. Now, for example, question 16, log base 3, you can pause and try and proceed, okay, if I'm fast. So 3 to the power of negative 3 equals 1 over 27, and definitely this is right. This was changing from logarithmic to exponentials. Okay, I'll get you 2 other questions from exponentials to logarithmic. Question number 19, 9 to the power of negative 1 equals 1 over 9. So here it's going to end up in log. What is the base? Okay, the base is always the number that has a power, this number. Log base 9, and this negative 1 was the answer, so equals to negative 1, and this was the one that was inside. So it makes sense now to me. 9 to the power of negative 1, 9 to the power of negative 1 equals 1 over 9. Question number, for example, let's say 21. 2 to the power of 8 equals to 156. So log, again, this is the base, it is the base over here, equals to, so here is the base, and here is the power, and here is the answer. Okay, so the answer is 256. And then check, 2 to the power of 8 is equal to 256, then you're right. Okay. The coming questions are evaluate. So for question number 25, log base 3, 1 over 9. And you have no calculator. You will set it equal to x. Okay? And then think, 3 to the power of x is equal to 1 over 9. And try to make the bases equal. So 3 to the power of x equals 2. Let me take this up, and this is 9 to the power of negative 1. So it's 3 to the power of negative 2. So this x has to equal to negative 2, and there's no other option. Question 26. Log base 4, 1 over 64 equals to, I'm going to put equals to x, and then think. Whenever I have a fraction here, I'm expecting the answer to be negative. Let's say equals to 64 to the power of negative 1. So 4 to the power of x equals, this is 4 to the power of 3. So 4 to the power of negative 3. So x equals to negative 3. Okay, I will not go through graphing because you don't have much of graphing, you know. Anyways, you just have to know the basics of it. So 8 to the power of x equals to 512. 8 to the power of x is equal, it's not 8 to the power of 2 because it's 64. I think it's 8 to the power of 3. So x is equal to 3. This was mainly this lesson and the graphing part, okay? I have lesson, what's next? 7.4, solving exponential equations and inequalities. I'll make another video for that, not to make the videos very long, okay? Bye.